All right, guys, so now we are going to work on this section number 2.5, lecture 2.5, part number 2, problem number 3. A road with 7% grade is 1.2 miles long. How high does the road rise over this length? So first of all, let's try to represent a road with 7% grade. 7% grade is rise over run, 7 over 100. But remember, the question is, basically, the question is how high my road is going when I have a 7% grade, which is basically referring to the angle theta right here, when my road is 1.2 miles, and what I'm looking for is basically h. So if I'm looking for h, basically I'm going to say, well, the sinus of my angle theta is equal to h over 1.2, therefore h equals sinus theta multiply by 1.2, and very often we are going to write 1.2 multiplied by sinus theta to avoid to have the mistake to have theta multiplied by 1.2, and then you take the sinus, and that will be the wrong answer. So as you can see that if I want to find the value of h, I must find the value of sinus theta. So to find the value of sinus theta, it's pretty simple. Well, I know based on the fact that there is a 7% grade that the sinus theta is equal to 7 divided by 100. Okay? Which means, just to remind you that, which means that we are basically dealing with, actually it's not sinus, it's tangent. Tangent theta is equal to 7 divided by 100, and I'm looking for sinus theta, so basically what I'm going to do is express theta as tangent to the negative 1 of 7 over 100. If you want to do this calculation and try to say, okay, well, theta equals 4.004172,941 degree, please take all the numbers. Or you can just write tangent to the negative 1, 7 to the 100 inside this formula. Now you know that theta is equal to 4.004172,941 degree. You can easily calculate h as 1.2 sinus of 4.004172,941, and you will find a value around 0.08379,49532 mile. Don't forget the unit. Now, how many significant number are you looking for? Well, you're looking for two significant number because you have 1.2 miles defined as two significant number, and that's the only value that you are dealing with. 7% grade is not defined as, it's not used to look for the significant digit, and theta is an intermediate calculation, so therefore the value of h is going to be 0.084 mile. Okay? If you are looking for a value in feet, well, you know that 1 mile equals 5,280 feet. If you multiply by 5,280 feet, you will be able to define the value in feet. And if you want to find that in feet, you're going to have 0.08379,495.32 multiplied by 5,280, and that will give you a 492 0.437 feet. $1.2 mile. 1.2 mile is defined as 1.2 plus or minus 0.05 mile. Therefore, we can easily say that 6,336 feet will be defined at plus or minus 269 feet. And so we end up to have a H equal to 400 feet. All right, guys, so now let's work on the problem number 2. On the problem number, not 2, problem number 4. On this problem number 4, what is the angle of elevation above the floor of a body diagonal? Well, the body diagonal in a room is defined in green right here. And then you have the floor diagonal. So when you look at the triangle ACB, you realize that the diagonal is equal to, using the Pythagorean theorem, we end up to have C is equal to the square root of 22 square plus 15 square, which is around 26.627, 0.054 feet. Now, if I look at the body triangle, end up to define that the tangent of the angle theta is equal to 8 over c. So theta equal 8, tangent to the negative 1 of 8 over 26.627,054 feet, and that gives me an angle of 17 degrees. All right, guys, so now let's work on the problem number 5. Suppose that you measure the angle of elevation to the top of a building to be 46.7 degrees when you step back 115 feet. Then, and measure the new angle of elevation to be 38.2 degrees. If your measuring instrument is 6 feet above the ground, what is the height of the building? So first, let me represent for you the problem. All right, guys, so I just tried to represent your problem. Please, when you're representing your problem, take as much space as you can. So we have the building right here. We have the building. You are at A, and I'd like to remind you that they are telling you that you are supposed to measure an angle of elevation. Then you step back, and if your measuring instrument is 6 feet above, remember you're measuring probably with at your eyes level. So what do we have is several triangles. And I try to define the first one. In the triangle BEC, E is a right angle, it's equal to 90 degrees. The angle B is equal to 46.7 degrees, as I was telling you that is supposed to be the angle of elevation to the top of a building. Then B, you're going from B to A, you're stepping back 115 feet. And now, the new angle of elevation, which is the angle A, in my triangle AEC, is 38.2 degrees. Then, if I look at, and I try to define the value of C, because I'd like to remind you what we are looking for is what is the height of the building. So I'm trying to find H. So if I'm trying to find H, what am I looking for? Well, first of all, what I could say is in my triangle, in the triangle BEC, sinus of 46.7 degrees equal to h over the hypotenuse, and the hypotenuse, if I call the hypotenuse E, over E. The point is I don't know E. Okay, I don't know E. Sorry for this noise. I'm receiving some email, I guess. I could look for the value of the tangent of tangent 46.7 degree, and the tangent will be h divided by the distance BE. But I don't know the distance BE. So what am I supposed to do? Well, first, let's try to figure it out, the angle, the different angle in a different triangle. So if I take the triangle number 1, which is the triangle ADB, I know that the sinus of the angle 38.2 degree is equal to A divided by 115. A divided by 115, and what is A? A is defined as this length right here. So I can easily define A equal 115 multiplied by the sinus of 38.2 degree, and end up to have a value around equal to 71.116965 feet. Also, I can define the angle, the complementary angle, being 90 minus 38.2 degree, and that will be equal to 51.8 degree. What is 51.8 degree? 51.8 degree is this angle right here, 51.8 degree. Now, in my triangle number 2, what do I have? If I look at the supplementary angle, I got 180 minus 51.8 minus 46.7, and I end up being equal to 81.5 degree. Knowing now that this angle right there is 81.5 degree, I can calculate the value of the sinus of this angle, the cosinus of this angle, and the cosinus of 81.5 degree is going to be equal to A divided by C. So C is going to be equal to A divided by the cosinus of 81.5 degree, which is going to be around 481.139627 feet. Finally, in the last triangle, BEC, and that reminds me that we are not calculating, it's not C, it's E that we are calculating right here, E. I can calculate the value in my triangle BEC. I can calculate the value of H by writing sinus of 46.7 equal H over C, and therefore H is going to be equal to 481.139627 multiplied by the sinus 46.7, and H will be equal to 350 feet. Therefore, capital H is going to be equal to 350 plus 6, which is equal to 356 feet. Guys, I'll let you do the problem number 6 by yourself. Pay attention to the graph to the representation